So then, now, you know, this doesn't seem much, but it's a very different question to ask and a different approach, because he's asking what's going on inside the frog, because in the previous approach, it's been observers outside the experience of the frog who are commenting on the frog's behaviour. So Maturana is saying, let's take a look from another perspective of what's going on inside the frog. Then he did another experiment, and he duplicated these, as you know, good scientists do. Like he went through this meticulously. He did another experiment on colour vision, and this time in pigeons. And what he did was he wired up the biologists will do wide up the pigeon's eyes so they could measure the activity of that part of the nervous system, right?
Oh, you don't mean wired it. He put sensors on the pigeon's eyes,
yeah.
so they could detect the movement or a rhythm.
Yes, yeah. So
He didn't wire them up.
no, sorry.
Stuck electrodes into their head.
Virginia was getting like that.
And then the other thing he did was, yeah, pigeons can observe different colours. So what they did was they measured the, is it electromagnetic, like the wavelength of the colour. So they had green, whatever the colours were.
Mm.
And so you're able to, so-called objectively, measure the wavelength of the different colours. So what he hypothesised is when this colour was shown to the pigeons repeatedly, you would get a correlation between the wavelength and the activity that was happening in the pigeon's eye, right? Like as they would measure the activity in the nervous system. And so when we showed a different colour, then we get a different pattern, but we get a pattern. And so if we did this with a number of pigeons, we'd hypothesise we would get this regularity of patterns. Show them the colours, same sort of activity in the nervous system, even though each pigeon might have its own different patterns, but we could begin to see the pattern.
And the pattern was the correlation between all of the pigeons recognising a particular colour by the movement in the pattern.
Yeah, each pigeon would have its own pattern.
Yeah.
If you like.
But there was a correlation of patterns around that particular colour.
That's what he
Indicating-
hypothesised
Right.
he would find. He found no such correlation,
Oh.
which was remarkable.
So to interject there, what we're saying is that the analysis of the signals that were passing between the eye and the brain, say,
Yeah.
had no correlation, no statistical correlation with the wavelength of the
Which
light
colour?
that was
Yeah.
causing those signals to be sent
Yeah.
across a selection of birds.
Which of course now open up a whole lot of questions like, what is going on? You know, when we say we see colour, what's happening?
And we all agree it's a blue carpet, or
Yeah.
but the signals in our brains are all different.
So then, like a good scientist, he conducted another experiment,
This time humans.
partly to test for the opposite, or, you know, the opposite in a way. Because you can teach pigeons through stimulus or classical conditioning, I think it's called, you know, that when we flash this colour, there'll be 3 taps, right? So the pigeons can learn to recognise the colours through that process, you know, the Pavlov, or not quite the Pavlov dog, but that type of thing.
Classical conditioning.
Yeah. And then when they showed before they flashed the colour, they did the taps for the colour to the pigeon, and then they showed the colour. What he found there was a correlation between the pattern of activity in the nervous system and the wavelength, because the pigeon was already seeing the colour, right, before it was flashed. And that's where he found there was a pattern. And so this is like, wow, what's going on here? You know?
So when you're saying found a pattern, there was patterns between lots of pigeons?
Yeah, yeah.
Different pigeons.
Like each pigeon would have its regular pattern. So there was a correlation that was established there.
The correlations associated with the taps, though.
Yes,
Yeah.
yeah.
The taps told colour. Yep.
And so that reinforced the whole question about, wow, what's the role of the nervous system in perception? And so as a biologist, he was interested initially in 2 questions. what is perception and what is cognition? And he came to see that that's actually the same question. Like, to perceive is to actually cognise something. To perceive is to understand something. And so that was the, what I call the empirical basis for his, for the theory that he has subsequently developed. Now, does that, just want to check if that...
Can you just give me that definition in your words between perception and cognition? So to see is to...
To perceive is to cognise.
Yeah.
Yeah.
But then you just flesh that out a little bit more. So to perceive is to cognise, yeah?
Yeah.
Perception and cognition, there is a similarity, but then you went on to explain that by saying to see is to...
I can't remember what I said, sorry.
Okay.
But can I go back to just so I'm clear again, on the taps? So are we saying that the understanding that across the population of birds, the tapping created the same signal across the birds?
Well, not exactly, like each bird...
I mean, statistically, yeah. There was a clustering of...
Say if you're a pigeon and MJ's a pigeon, right? And so I train you that this is green.
3 taps are of green.
3 taps are green, 4 taps are red.
When I see green, I have a different signal than when MJ sees
Yeah.
green. But then when you do the taps that mean green...
No, even when, well, you don't necessarily have exactly the same activity in your nervous system, right? But there's a regularity in the pattern in your nervous system when I tell you that we're going to show green.
That's what I mean. I mean, simplifying it into saying that they are the same pattern or not the same pattern. When you show me green, I have a different pattern always from MJ.
Yeah.
But when you give me the signal that green is coming, we both have the same pattern.
No, you
Or similar.
Well, no, it wasn't so much that, I don't think. And I haven't been able to get hold of the actual paper. They wrote it up. But I talked to one of the graduates who went to Chile and said, look, how did he do the labelling of the colours with the pigeon? And he said Maturana did explain it. The point is that if I show green to you and green to MJ, you're not necessarily going to have the same pattern in your nervous system, but you are going to have the same pattern every time I tell you the green, I'm going to show you green.
Are you guys the same?
Yeah, I think we are the same thing. So
Okay.
if 3 taps means green is coming,
Yeah.
and you measure the signal in my brain at the point of
the traffic lights.
MJ and I have the same signal when you do the 3 taps, but we have different signals when you actually show us the green. 3 taps means green. You show us green, we have a different signal. You show us each 3 taps, and we have the same signal.
No, it's not the signal, it's the activity. We have
Yes.
individual patterns, but there's an increase in correlation.
What
activity.
what he was correlating is that when I tell you I'm going to show green,
Mm.
and I show you green, your nervous activity has the same response
Mm.
As?
all the time.
For green.
Every time I show you green,
But only when
You
you're
get
told
the colours.
first.
only when you're told first.
I'm confused now. So you mean every time you show me green, I have a different brain pattern?
No.
Every time you show me green, I have a brain pattern.
So there's 2 things. I show you green and I tell you it's green. And that's where he found there was no correlation.
So the next time he showed you green, it's a different pattern.
Yeah, yeah. So let me try and sketch it on the board.
Please, I'm sorry to leave it.
That's okay. No.
Beth?
So here's, so this is experiment 1.
No.
No prior information, I just show you green, okay? Green, and I'm expecting you're going to have the same pattern here every time I show you green. And what I find is there's no correlation between the wavelength of green and what happens in your nervous system.
From one exposure to green to another.
Yeah, yeah.
So I do not consistently repeat a pattern in my brain when I see green.
When you see green.
Okay.
So it's not that I don't correlate with the green, that I don't have the same neurologic activity as MJ.
It's
Okay,
not
that's
comparing
irrelevant.
pigeons.
Okay,
So it's
So-
comparing it internally to
Internally.
me.
Every time I see green,
Yeah,
I have a different neurological pattern.
yes.
Every time I hear the signal that says green's coming, I have the
Yes.
same one.
Yes.
Yes.
Okay, that's very clear,
Mm.
but